In this video, we'll look at the XPack plugin called Timelion, which is a time series analysis tool. First, we'll go over what time series analysis is and what Timelion is. Then we'll create a time series to show you how we can graph specific data. We'll look at some of the time comparison and multi-time series analysis. We'll look at functions, and then we can figure out how to use external data. So Timelion is a nice visual way that you can make time series graphs and visualizations. So we can combine different time series from disparate sources. So we can have two Elasticsearch clusters all being queried by the same timeline interface. We can build custom visualizations. We can change characteristics of the graphs that we're building. We can change the visualizations of the graphs we're building using a almost programmer-like interface with nested functions and linked functions. So the first thing we're going to do is we're going to find data from our index. We're going to look at our metric beats index specifically. First, let's plot our CPU utilization here. So we'll come over to Kibana, we'll click on the Timeline tab, and that'll bring us to this page. And now you can see up here, this is a combination of search, building a search, as well as defining what you want your graph to look like. So by default, we're counting documents. So Elasticsearch has this number of documents completely in total across this time series, or that time frame. So now let's change this. So now I'm going to keep this .es for Elasticsearch. I'm going to tell it what index pattern in Elasticsearch to use. So I'm looking across all metric beats. I'm using a time field of timestamp because it is all time series analysis. You need your time field. Then we're going to look at the specific metric. So we're going to look at the metric we're going to call the function average. So we want to be plotting the average CPU utilization percentage. So I'll hit go, and you'll see that this started to plot. So I can expand this. Let's expand that to make it a little better. So here you can see our CPU utilization went up a little bit, and I guarantee you this is the past hour or two when I've been recording videos versus when I first installed metric beat. So that's pretty cool. So we see our CPU utilization. Next, let's add memory next to that. So let's copy this, and we want to find system memory used %. And since we have this comma in another data series, we should map these two things together. System memory used %. There we can see now we have a percentage of memory utilization. So you can see it kind of trends along this small, under 25% utilized. And when our CPU spikes and utilizes, most likely your memory is going to go up as well. So here you can see that we're plotting these two data points just by building out this list of queries up here. All right, now this is one of my favorite pieces. So let's compare this data to an hour ago. So they have this offset capability where I can build the same graph that's looking at data now, and then I can map it immediately to the offset of the older data. So let's take this CPU utilization, and again, let's map it. Okay, so that's what it looks like. And then here, we can compare it to the hour before. Offset equals -1 hour. Now we'll hit go, and you can see, so compared to when this CPU utilization here, it's comparing it to the hour before. More accurately, so here you'll see the red is an hour, it looks like an hour ahead of the green. So green is real time, and red is comparing the green before. So we have at this moment in time, the average CPU utilization, the green, is 0.02. The red is 0.26, so that's why the red is above it. That's the hour before the green, which means the CPU at this moment in time is used significantly lower than before. So we can do those offsets for last week with 7 days. We can do all kinds of offset comparisons here. So if you're comparing your company's revenue, you can compare your revenue to a year ago, since that's usually your seasonal patterns are annual in a retail business, or depending on your business. You could have those comparisons over the year. So really, truly compare your apples to apples. Compare your March to last year's March. And you could even do it 2 years. You can do another one for 2 years before. So, but what you saw, I couldn't really tell which one they are. So let's add a label to our data set. So we'll come over here, and this is those chain functions I was talking about. So you have here your first plot line. I'm going to say dot label, and we'll call this now. Everything happening now is happening now. So we'll hit now, and you'll see the green is now. So now we can add the same label to the next one, 24 hours ago. And we can hit go, and you'll see our red is now labeled as 24 hours ago. All right, now let's add a title to our chart. So this title has no chart, so we'll find our last metric, and we'll do title, parentheses, time analysis of my CPU. We'll hit play again, and now we have a title on our chart. So these are the easy configurations and personalizations you can do on your chart. So now we're going to do a little color, so we'll add little lines here with a fill and a width. We'll add lines, so we'll come in here, we'll add dot lines, fill equals 1, comma width is 0.5. And then we'll continue into the label chain function, title chain function. We'll hit play, and now it's hard to see here, but let's zoom in to the last 15 minutes, last hour. So now you can see the red is the historical. So we put a thin 1 pixel line on it. A thin half pixel line on it with a fill of 1. A documentation will tell you all the other visualizations you can add to it. So now you can do a bunch of functions. I'm not going to run through all these, but we'll be able to figure it out. So we have a math function. We can do static values. We can do absolute values, log of a value. We can do derivatives, trending. We can split in our map, which is just like any other Elasticsearch group by, where you're splitting your map. You're drawing your different functions per field. So in the other data set, we could split a line per restaurant name, per DBA. Or we can do a static. So we'll take this static 25 and we'll add a label to it. And we can add that static value by typing .static. And this will give us the hints down at the bottom. We can do the value label offsets and fits. So we'll do a value of 10. And we'll do a label of fixed 10. And we can press play. Label is equal to fixed 10, not a function. And now we have our 10, so our static 10. So it's a couple of different things you can do. You can find the log value or the negative value or the any sort of data you want to find here. Any functions you want to run, you can. All right, so now we have wrapped up our XPack learning. We started with security for how we can build permissions, roles, and users, and put the users in the roles, assign the permissions to the roles, etc. We looked through the graph capabilities, linking data together, filtering and drilling across data visually in almost a force-directed graph view. We looked at machine learning to find the anomalies in our data set for counting New York restaurant inspections, and so that machine learning shows us the patterns that the computer could find that we probably wouldn't find. We looked at APM, or the Application Performance Management module, and how we wired in some code to our Python script or our Python application to get metrics into Elasticsearch. And then finally, we just finished looking at Timelion, or the time series analysis. In our next and last section, we're going to talk about scaling your Elasticsearch cluster. We're primarily going to be looking at Elasticsearch. We'll look at some Logstash scaling as well. But for now, we'll look at the overview and figure out how we can make our Elasticsearch cluster as big as it can be to meet the needs of our business.